When we add fractions, we have to make sure that the two numbers on the bottom are actually the same number. What is the trick to make the numbers on the bottom the same? Well, a very simple trick is to actually times them. So when we look here, we've got a 5 on the bottom of one of the fractions and a 3 on the bottom of the other fraction. And so we can do a trick where we actually times 5 times 3. Let me show you what I mean. So in the first fraction, I'm going to go 5 times 3, and then up the top I've got to do exactly the same thing. Now with the other fraction, I've got to do 3 times 5, and up the top I've got to also do times 5. What does that turn into? Well, it turns into a 15 down the bottom and a 15 down the bottom here, which is awesome. 2 3s are 6, 1 times 5 is 5, and now we're allowed to go ahead and add these fractions because they've got the same number on the bottom, the same denominator. So we put 15 down here. 6 plus 5 is 11. In this sum, we are going to add 2 over 4 plus 1 over 3. And so we know that the very simplest way that we can make both those bottoms numbers the same is to times them together. So here we can go 4 times 3, and over here we can go 3 times 4. Let's simplify it now and see what we get. So we've got a 12 on the bottom, which we just love because then we've got the same denominator. 2 3s are 6. 1 times 4 is 4, and so now we put the 12 down again. 6 plus 4 is 10. So that's definitely one way of writing this answer, but we can simplify it a little bit further. We can make it just a little bit easier to understand, and we can say that actually if we divide this one by 2 we get 5, and if we divide this one by 2 we get 6. So that's just a slightly easier way of saying the same fraction. We just did a bit of dividing at the end to make it the simplest it could be. When we look at this set of fractions that we're going to add, 1 over 3 plus 1 over 9, we could do our usual trick of timesing the 3 and the 9, but there is another way forward. We can actually just take a look and think, you know what, if I times this one by 3, I'm going to get it to be 9 on the bottom, which is just perfect because I need both numbers to be the same on the bottom. And we don't have to do anything to the 1 over 9. So then, when we look down below here, we've got a 9 on the bottom and a 3 on the top. We can add that to 1 over 9 because they both have the same numbers on the bottom. And so now what we've got is an answer that says 4 over 9. It's a bit tricky when it's time to add 1 2/3 to 2 1/4 because we're not really able to push ahead unless we sort out the whole numbers. So here's a way that you might want to proceed. You can add the 2 whole numbers first, which is the 1 and the 2 can be popped over here, and we know that that equals 3. And then we can go ahead and we can think to ourselves, all right, we've got 2/3 plus 1/4. Now we know that we just can't go ahead and add these until we've made the bottom numbers be the same. And so we know our simple trick is to multiply 3 times 4. So over here I'm going to go times 4, and over here I'm going to go times 3. Let's see what happens. So down the bottom I've got the 12, which I'm really happy with, and up the top I've got 2 4s are 8. Over here I've got 3 1s are 3. When we add them up, we still keep that 12 the same, but up the top we add 8 plus 3 equals 11. Now we need to bring up the 11 over 12 and add it to the 3 up the top. And so our final answer is 3 11/12. When we times these kinds of fractions, 1 4/5 times 3 1/3, we've got to do a little bit of work before we can begin multiplying. So let's take a look at 1 4/5. First of all, we've got to actually turn that number into, the whole lot's got to become fifths. So there's a little trick here. You go 5 times the number that's the whole number, so 5 ones are 5, and then you actually plus the number on the top. So 5 ones are 5, plus the 4 is 9. So that's what that has actually become, that number. Similarly, let's have a look at the 3 1/3. So you do a little sneaky multiplying thing. 3 times 3 is 9, and then you actually plus the 1 at the top. So 9 plus 1 is 10, and it's over a third. So now you can start multiplying. When you do this, you can actually go across the top and across the bottom. So let's go. 9 times 10 is 90. And down the bottom, 5 times 3 is 15. Now we've got one more bit to go. So we say to ourselves, how many 15s in 90? It actually goes 6 times. So what we do here is we say, okay, 15 goes into 90 6 times. If you're interested, there's another little sneaky trick that you can use before you even start multiplying. So let's go back again and have a look at this sum at this point here. Because what you can actually do is you can go crisscross, you can go, how many times does 5 go into 10? It goes twice. And you can go, how many times does 3 go into 9? It goes 3 times. And so then what you're left with is 3 times 2, which makes 6. So that's just another little trick if you want to have a go at that one. Sometimes you've done a sum with fractions and you've ended up with the answer, perhaps it's 12 over 15, and you say to yourself, is that the simplest way that I could say that? And the thing is, there's just one more step to make this look even simpler. So how do you simplify an answer that's a fraction? What you do is you think about your times tables. Is there any number that divides into the top number and into the bottom number so that we can simplify it? And looking at this, I can definitely see that we can divide 3 into the top number and into the bottom number, because both these numbers are answers in our 3 times tables. So I go, okay, how many 3's in 12? 4. How many 3's in 15? 5. And so that's really a simpler way of saying 12 15ths. Sometimes we end up with an answer in fractions where the top number is actually bigger than the bottom number. Are we actually allowed to leave it looking like that, or do we have one more step to take? We definitely do have one more step to take, and that is we have a think about our times tables again. So we actually say to ourselves, how many 5's go into 12? So we're having a bit of a think about our 5 times tables. And so what we actually know is that 2 5's go into 12, and so we can write that down as the whole number that's going to be part of the answer. So we know that 2 5's go into 12, and we know that there's 2 little bits left over. And so that's how the answer needs to look when you've simplified it.